Hello, welcome to 8.10 Graphing Rational Functions. You may need to pause this video and open up the notes in case you will be because you'll be using them instead of just following along with me. Okay, there will be many times we have to pause the video. All right, so take 4 minutes and start the launch. So go ahead and pause the video and then start the launch. Okay, welcome back. Here are the answers to the launch. So the vertical asymptote is none. The horizontal asymptote is y equals 0. The whole, there is none. And the zeros, there are none. Okay, the second example, you should have factored this, x minus 3, x plus 3. Your vertical asymptote is x equals 3, x equals negative 3. Horizontal asymptote is y equals 2. The whole, there's a whole, there is no whole. And the zeros, there is a 0 at x equals 0. Okay, this last one should be simplified or factored, excuse me, x plus 4, x minus 1. Vertical asymptote at x equals 2. The horizontal asymptote, there isn't one. The whole, there isn't one because there are no common factors. And the zeros at x equals negative 4 and 1 because I took the numerator and set them equal to 0. Okay, today's lesson is all about being able to use a table to graph rational functions. We're going to do the first example together and then you'll pause the video and have the rest of these problems done. And you may want to do one and then watch one done so that you don't get too confused. One thing that I want you to keep in mind as you go through them is you are going to be using your analysis as well as the table to graph these functions. So you are still going to make a list of what is the horizontal asymptote, what is the vertical asymptote, where are the zeros, and are there any holes in the graph? Okay, and you can go ahead and list the domain as well, but the domain will be obvious from what you're doing in this problem. So first of all, we go through horizontal asymptotes. I see that it is bottom heavy, which means that my horizontal asymptote is y equals 0. For a vertical asymptote, there is no value that would make the denominator 0. So we actually don't have a vertical asymptote here. Zeros, the numerator is a value that can never be equal to 0. So none. And then holes, there are none of those as well either because as I factor these, nothing is in common. Okay, so go ahead and mark in what the asymptotes are. Okay, so I'll do my asymptotes in green. Okay, so there's one here along the x-axis. That's the only thing I have so far. Okay, so putting these values in, you need to be very careful with the math. Okay, so there's not a lot of room here, and you may want to use a calculator at some point with these. But go ahead and just like we did yesterday in the notes, you're going to put this number in for wherever you see x. So 6 is the numerator, negative 4 squared plus 1, and I get 6 over 17. Okay, you might not know what that is as a fraction, and I'll talk about that when we go to graph them. So 6 over 17. Then we're going to put negative 3 in here. So 6 divided by 9, because that's negative 3 squared plus 1. So 6 divided by 10, which is 3/5. I put negative 2 in here. 6 divided by 4 plus 1, and I get 6/5. Don't worry too much about what the decimals are at this point. -1, 6 divided by -1 squared is 1, plus 1 is 2, so my y value is 3. Put 0 in here, I get 6/0 plus 1, so my y value is 6. And when I put 1 in here, I get the same thing. Sorry, 1 plus 1, I meant I get the same as just above it, is 3. In this case, the negative and the positive values end up being symmetrical. So when I put 2 in here, I get 6/5. That doesn't always happen. This is just a special type of problem. Put 3 in, I get 3/5, and with 4, I get 6/17. Okay, so now you're going to come over here, we're going to start plotting these. So I have -4, comma, 6/17. Well, 6/17 is pretty close to 1/3. If it was 6/18, it would be 1/3. So we're going to approximate. So -4, and here's 1/3. I'm going to go over -3, 3/5. It's a little more than half. So -3, 3/5. -2, 6/5. More than 1. So that's going to go here. -1, 3. Now we get into integers. 0, 6. 1, 3. 2, 3. Oops. 2, sorry, 6/5. 3, 3/5. And 4 is right down here. So here's what this graph looks like. I know I have a horizontal asymptote here. So the best I can do with this drawing program, that's what the graph is going to look like. Something like that. Use the asymptotes as your guide, okay? So now you're going to pause the video. You're going to do the next one. Maybe you'll have to pause in between. I'm not going to have too much talking, but you're going to be making this list and making the y values. This is tough to do. Okay. So I'm not making a list, but you should make sure that you have a horizontal asymptote at y equals 2, a vertical asymptote at x equals -3 and at x equals 3, and a 0 at 0. Those are all the values you should have. Okay, so this is exactly what you should have on your papers. Okay, so now we're going to go through a bit of a review of addition and subtraction of rational expressions. Okay, so first of all, these first few, very quick refresher. You have a common denominator with the 4x's, so we can just add them together. So our answer is simply 10 over 4x, and we simplify to get 5 over 2x. Okay, denominators are the same, so I can just go ahead and subtract them. No issues, okay? All right, here I need to do some factoring. This is really 3x quantity squared. This is 3x times x plus 1. Because the reason I'm factoring is I want to see what common factors there are. And I want to make sure that you write down somewhere what your least common denominator is, okay? That's the first thing that you're going to check as you go through these problems. Do you have the least common denominator right? Our least common denominator is going to be 3x quantity squared times x plus 1. Oops, x plus 1. There we go. Because this has two 3x's, so this needs to be the greatest of those. And this one has an x plus 1. So what I've been saying in class is that your least common denominator must be divisible by both of these. Okay, so 3x squared times x plus 1 is divisible by 3x squared. I have left over an x plus 1. This is divisible by the 3x times the x plus 1. Okay, all right, so now we have to multiply. We're going to multiply this fraction by x plus 1 over x plus 1 because that's what's missing. We're going to multiply this fraction by 3x over 3x because that's what's missing. By multiplying my denominator by 3x, I will have 3x squared and then times x plus 1. So when we put that all together, we have 7 times x plus 1, x plus 1, plus x times 3x, all over 3x squared times x, I keep missing that, and plus times x plus 1. So my numerator, when you simplify it, and I would like you to simplify it in your notes, you can pause the video and make sure you get the same answer. When you're all done, 3x squared plus 7x plus 7 divided by 9x squared times x plus 1. That should be your final answer once you multiply everything out. Okay. All right, what I'd like you to do is pause the video and work on these problems. Then you can come back to the video as you need help. When you get to 6, do not simplify it out. This could be really icky. Okay, so I'm going to be writing what the least common denominator is and then what my final answer is. Okay, my least common denominator here. Remember that you have to factor here and you have to factor here to find that out. Okay, the final answer, all simplified. So as you're going through these, if you don't have that answer, then you're going to want to be able to check with somebody. Okay, here, this last one, your least common denominator is they have nothing in common, so it's all of them. Okay. So my final answer, because I said don't multiply it all out, okay, and then 5x times, oops, I'm not going to fit it in here, x minus 4, oops, you can't see it, it's x minus 4, all over, and then I'm just going to, this is what your denominator is. Okay, all right, last piece. So let's refresh our memory with how to do these problems. Okay, so mixed operations with rational expressions. We'll do the first one together. We'll talk about 2 or 3, and then I want you to pause the video and then keep going with this. Okay, so let's combine the like terms together. So I have x over 3 plus 4 over x plus 4. So I need to find a common denominator. Okay, my least common denominator again is 3x. So I'm going to multiply all of these pieces by what's missing. So x times x plus 4 times 3 plus 4 times 3x all over 3x. You'd simplify and your final answer is x squared plus 12x plus 12 over 3x. Okay, so these are a little bit trickier. This is called a complex fraction, and we're going to learn about this in just a couple of days. Okay, so a fraction is you're dividing a fraction by another fraction. So when you're dividing two fractions, it's really the same as multiplying. So you need to rewrite this one as a multiplication problem. So 15x minus 3 over x times 3x over 4 minus 20x. Okay, so I'd like you to pause the video and do some simplifying. So simplify here, and see if you get the right answer. Okay. Okay, did you get it right? I bet you did. Maybe you forgot this negative. This was a problem on the quiz. Okay, maybe that was something that got forgotten. Okay, this one, same thing. Okay, so you'll do your simplifying. Again, you might want to pause the video. And there's your answer, 7 over 4x. Okay. All right. This one has a lot more work to it. You have to simplify here, multiply by the reciprocal of simplifying here. Okay, so you're going to pause the video and then do all that work and then come back. So my least common denominator is the x minus 2, x plus 2 that we get from right here. X minus 2, x plus 2. Okay, all right. Okay, oops, I wrote that wrong. Okay, there's my common denominator. So I've multiplied the 3 by the x minus 2, the 1 by the x plus 2. Okay, so that's what it would look like. I'm going to get rid of that. Hopefully you wrote that down. Okay, so then what I really have is x plus 2. If I simplify all of that, okay, what happens is this cancels right here with this. My final answer is 3x over 4x minus 4. Okay, and that's it. Okay, so you're going to stop the video, and if there's still time left in class, you're going to start your homework for the 8.10. It's posted on Classroom. If you need to go back to some of this, then please make sure you do that. Okay, see you Monday.